Hey guys, welcome back to the channel. Tonight we will be working on this 2007 Mercedes S550, and this gentleman actually came from almost about 2 hours away from Indianapolis. He's been having trouble and chasing a misfire issue. He's done a lot of work to it and found me on YouTube through one of my videos, I guess related to misfire diagnostics on Mercedes. And it gave me a call, asked if I wanted to look at it, because he was done putting a lot of time and money into it. And before he went any further, he wanted me to see if I could find out why it's misfiring. As far as the issue or what is going on, he says that it's continuously, or it will misfire on cylinder number 8. And it's not like a dead hole all the time. It'll drive okay, but then you'll get a just a misfiring error come back, and you can feel it, and you can cycle the key. It'll run decent until it starts misfiring again. So he says it's always on number 8, and he's replaced a lot of things on the vehicle, from your basic coils, plugs. I think he's moved injectors around or had them cleaned. Even had the computer sent out, supposedly tested, checked, and I think cloned to a different one. Same issue. He's done cam sensor, crank sensor, the variable cam control solenoids or magnets, whatever you want to call them. So he's done a lot of things, and he's at the point where basically he wants someone else to take a look at it. And I believe he's also done compression test. He says it's I think okay, or about the same as the others. But let's get you a shot of what it has as far as trouble code. So I've just done a full scan, and let's see what the engine computer has. Alright, so there you go. It's pointing towards number 8, and it's got a PO 300. So for right now, that is basically confirming the customer's complaint. And let's see, as far as it's confirming the trouble code as far as his complaint. As far as how it runs, pretty decent. It's not a dead hole miss. It's not a continuous miss. You could maybe feel a slight tumble. But so that's what we're here to chase and find out. I have started sort of looking at it off camera, but being what we've got, I think I'm going to bring you guys along and see what we can find. And as with any misfire diagnosis, I will start with a relative compression, just because I don't want to waste any time diagnosing anything else if there is a mechanical issue that is seen with relative compression. We can keep in mind we can still have some sort of mechanical issue that won't be seen in relative compression. As far as the identification, this is bank 1, this is bank 2, 1, 2, 3, 4, 5, 6, 7, and our trouble child, number 8. As far as my setup, I've got my amp clamp on my negative cable, and I've unplugged all coils. There we go. Actually, that one stays on. I am leaving number 1 on to get the ignition sync. The rest are unplugged, and I do have injector 1 unplugged since that's still in there. So you just want to disable it from running. Let's get a look and see what it sounds like and what it looks like. Okay, so let's take a quick look here. So we are going to look for any lower than the other on the humps here. Each peak and rise is a cylinder coming up on top dead center, building up compression. If we clean this one up a little bit, there we go. So not one seems to stand out as far as being lower in compression. So we've got, here's our ignition, here's our ignition. So 1, 2, 3, 4, 5, 6, 7, 8, back to 1, and our firing order is 1, 5, 4, 2, 6, 3, 7, 8. So 1, 5, 4, 2, 6, 3, 7, 8. So here is our suspected cylinder. It's 1B4 number 1. So we can actually scroll through the waveform. If you notice, I did crank for a long time because you want to try to keep it going for a while to see if maybe in one cranking event it doesn't show its ugly face, but in another it might. That is why I crank for a decent amount of time. And here, so far, number 8 seems to match all the other cylinders. So by the looks of it and even the cranking sound of it, it doesn't appear that we have a dead hole at the moment. So based off of that, our relative compression coming out pretty much a normal looking capture without any cylinders showing a defect. I want to monitor a couple things while I get this started idling and running and get it up to temperature and see if I can get it to misfire while idling here. And with the things that I will be monitoring, I'm looking to see if I can capture anything. One of the things that he was concerned with, and I guess I'll be looking at, was the control or activation of the coils and injector. I think it's part of the issue as to why he was questioning the computer. So I will be looking at ignition sync for number 1, just as a sync. I'll be looking at coil control and amperage for number 8, in case it gets to a crazy high level where it'll maybe shut off or not, but we're not having trouble codes for any type of circuit thing, but we'll still monitor that. I'm going to monitor the control voltage of the injector number 8, and I will be looking in the intake trace and also the exhaust. So let me get all that set up and bring you guys along. Okay, and just before I get it running, I'm going to do crank no start while also monitoring the intake and exhaust, since I've got those hooked up to use when I'm idling. So let me get this started. Let's crank it and just get a visualization of how it's breathing with intake and exhaust. What I like to do during cranking is to also look at the intake pulses and exhaust pulses, because again, we are watching the engine move air during its cranking state, cranking speed. We're watching our camshaft, our lobes, our piston compression, our intake pulls, everything. Each cylinder is built the same, and it's supposed to act the same and pull the same amount of air, push the same amount of air, build the same amount of compression, so on and so forth. It's a physical thing that you cannot get away from as far as what the engine is going to do with the air. And so, just like relative compression, we want to look at the pulses and humps for the intake and exhaust, and all those should be about the same compared to other cylinders, both in intake and exhaust, just like how we want to see in relative compression. And if we take a look here in the exhaust, exhaust is very difficult, or it's probably the more difficult one to analyze, but on this one, during cranking, nothing really stands out as being crazy abnormal or missing, or so on and so forth. So all our pulses seem to be about the same compared to one another. So physically here, we are not seeing something at cranking on the exhaust side, and then kind of the same on our intake. If we move up here and zoom in and we clean up this channel, we see that from ignition strike over to ignition strike, we have 1, 2, 3, 4, 5, 6, 7, 8 pulses within that cycle, and they all pretty much look the same relative to the one next to each other. And there's not one at this moment during cranking when it's pulling air in that seems to look different than the others. So at this point during cranking, we are not seeing any difference in compression pressure based off amperage. We're not seeing any exhaust pulses, movement of the air coming out of the exhaust. We're not seeing one look different. And again, in intake, we're not seeing any of those different. So cranking, testing, pressure, pulses, reading is not giving us a direction at this moment. Alright, so I am all plugged in as far as coils and stuff to get this engine to run. So let's get it idling and see what it looks like. Okay, so as it's idling, let's go into the engine computer. See if it has like live data and showing misfire counting. So again, we still got the scope going. We will analyze that here in a little bit. I don't feel it right now as far as like a stumble or a misfire, any of that at the moment. Okay, so it's there. Let's see, where are we? Alright, so to my surprise, at the moment this seems to not have any display for live data checking misfires. So with that, I guess we will go ahead, and this is a big part of why I am a avid preacher of using the scope, not messing around too much with scanners all the time, but we'll keep this rolling and see what we find. And just to get you a shot, so when I was sitting in there looking at the scanner, I could start to feel a little bit of the rumble. One thing I've noticed, now take a listen. Alright, so hopefully you've caught some of that over the camera. Let's take a quick look. Okay, so here is the capture that we just gathered from it idling. Couple things to point out, or that we'll go over. Again, number one is, or channel 1 or blue is our coil number 1. Red is coil 8. Yellow is exhaust. Green intake. Purple is injector 8. The teal blue is amperage for coil 8. I think that's it, but let's take a look at it. Obviously, right now, blue doesn't matter. Yellow and green, we'll go over here in a bit. The other ones that we want to look at was the, let's see, coil 8. So red is the control. This blue is the amperage. And yeah, there's a little bit of noise, but basically here is our turn on, and then that is our amperage. Now the amperage peak is a little bit high. It's close to 13 amps, but right now, for the moment, I'm just going to keep that in the back of my mind. Obviously, it's easy enough to scope a different coil, which I might hear later. But we do have control, so turn on of the coil. And obviously, we are firing, and there's our amperage for the coil. And here in the purple is our injector. And so we do have, first and foremost, control of the injector. There is our pintle hump movement, so we can assume that we are opening and moving fuel, which again, it's not a dead miss. So yes, we are contributing fuel to the cylinder and firing it. Later, I might watch the fuel flow, but and compare it to others. But I might not have to. But for now, we've got coil control, coil amperage, injector control, pintle movement. So I, for the moment, will get rid of those channels. And so what we've got here left is, obviously, this is our coil for 1, which we use for a sync. I'm monitoring the exhaust to attempt to try to catch when a misfire occurs. I would have liked to have seen a great spike throughout the capture when a misfire happens. Now, maybe I'm expecting too much as far as seeing a high peak. That would definitely be for a dead hole. So I got to keep in mind that it seems to be like a partial combustion. We can sort of feel a blip of a miss. So it's combusting, just not fully burning. And I've had quite a few here on the channel where that has been the issue. If we zoom in, we can definitely see some sort of non-rhythmic or a rhythmic difference, let's call it, in this area. Looks like this area, this area, this area. So there seems to be something going on that is continuous. It's not a full spike like dead holes again. I just keep reiterating that, but we have to try to realize what we are looking at, based off also tying it together with the symptoms. Again, it's not dead hole, it's partial combustion, and I think that's what we are seeing there. And we can try to use the sync to try to identify a cylinder. But the other thing I want you to look at, and this might be where that funnel narrowing path leads us to. We do all these tests to try to start us in a big area and lead us down to a basically bullseye. Now, and it's because I've spent a ton of time on this before on a similar situation, a Mercedes, that I am paying particular attention to the intake waveform. If you look at this section, it's kind of stagnant, and there's some point of, let's call them activity or blips, that you can see it from this far away of a view. Let's see, if we blow it up, it's more prominent that there are some blips there. If we, let's see, go back, let's go to our next capture. There's some more, again, from the far out view, but let's blow it up. And there you go, it's more prominent again. And the next capture, again. And then I'll just go all the way towards then here's a good one. That's definitely, look at that guy there. And so at idle we should be steady. And there, just before I turned it off, there we go, another prominent one that sticks out. So this whole time at idle we should be steady, not having any issues. And this is somewhere in that region. And so again, on our exhaust, looks like there's that same activity. It might be a little bit greater in this area where that intake blip occurred. Let's see if we can sync this. So okay, so it looks like it's just after. Let's see, somewhere in that area. So it actually looks like it's kind of small, and then it kind of gets a little big as that when we sync that to the intake area. You might be able to guess as to where my kind of direction is headed. Not only are we seeing activity blips on our intake waveform trace that should not be there at a steady idle, but with our physical being while we visually are in front of the engine, I tried to point out, and hopefully again it captured it, we are hearing kind of the same similar blips coming out of the intake, out of that mass airflow. So we know we should not have pops and blips and stuff come in through the intake. But if we tied that with what we hear, what we physically are experiencing, and then with the data that we have just gathered that we see blips on our intake, I can almost bet you, and again, based off experience, I had this one other time, I'll actually link it. It took me about a week to figure out. I just dedicated on that one car for a whole week. I kid you not. I wouldn't say I wasted a lot of time. I learned a ton from that car. And it once it clicked, once I figured it out, everything from there has been a little bit easier to try to identify. That one had a leaking intake valve. And this one is basically looking about the same way that that one did, especially with the intake trace waveform. Okay, so I wanted to bring you guys along. I've been checking this a lot off camera, trying to pinpoint something. Looking at the exhaust, it was difficult to try to pinpoint a specific cylinder for the Misfire. Now we know the scanner is saying number 8, and I'm just trying to verify the scanner's tattletale. That's why I was trying to look and identify through the exhaust. I know I was explaining about the possible intake situation there that we kept hearing the popping and so on and so forth. what I wanted to do again was still try to verify the misfire and see if we can correlate that some way, somehow, in the intake trace. So what I ended up doing was moving over to monitoring the CKP, crankshaft sensor, and with that I can create and build a math channel that will watch for crankshaft speed, and if there's a misfire, we'll watch and see the speed of the crankshaft slow down, because a cylinder won't contribute to adding speed to the crankshaft. So that's the purpose of monitoring the crankshaft sensor, and that's in red. Number 1 is ignition sync 1. That's always the one I'll use for sync to identify cylinders. Green is still intake. I decided to also go on a test drive because the customer stated it's more prominent once you get driving, and you'll feel it misfire, and then you'll cycle the key. So basically what's happening is it seems that a cylinder doesn't combust properly, and then it'll shut the injector off, and that is what the customer is feeling. I've been seeing a lot of this, and I've got a couple of videos where it's events that are happening prior to what you physically feel. So the engine is basically just not combusting and burning properly, and so it'll shut off an injector, and you feel a dead hole more than you feel an improper combustion. So that is that's pretty much what's going on. And so I'll get you a shot, hopefully here on camera. The check engine will start flashing once it goes into like a full miss, and then after you let off, and it'll miss while accelerating, and after you let off, it's at a full dead miss because it shuts off the injector. There we go. Finally. And so as soon as the green dropped off, I let off because the light was flashing, and now we are, I know you can't hear it or feel it, but we are in full shake mode, and I will get you a shot of that. And you can tell the intake is not stable. That's because idle is surging. We are in full shake mode. The injector is shut off. And just to show you and verify with the scanner, okay, so now both those are stored and current. It switched over to current, so it's saying number 8 is missing. And again, we are surging. Injector is shut off at the moment. Now, the capture that I have here is one that I use the crankshaft sensor to try to find the misfiring cylinder, to see if we can verify with the scanner if it is truly number 8 and only number 8. And that way we can put the rest of our efforts into deep diving into cylinder number 8. So, again, our exhaust pulses were making it a little bit difficult to identify a specific cylinders. So this is why I moved to the crankshaft sensor. As far as our channels and how this works, the red channel is our crankshaft sensor signal. Intake is still in green, and this is at idle. And the blue that's back here, that is our ignition trace for cylinder 1. Again, I use that as a syncing method to identify cylinders, and I'll show you how. The black channel here, this is one that is created and derived from the crankshaft sensor signal. The crankshaft sensor will read the speed of the crankshaft, when the engine is turning. It's our RPM pickup, so on and so forth. But just looking at the crankshaft sensor signal with our naked eyes, we cannot depict and decipher speed fluctuations. So that's why we, with the scope, we can create a math channel, that's what it's called, which is derived from that and gives us the speed fluctuations. That's what the black channel is, and how or what I am using it for is to watch the speed fluctuations or the speed acceleration of the crankshaft when a cylinder fires and combusts. All cylinders have to create the same amount of crankshaft acceleration when they fire the spark plug and combust and push the piston. All cylinders are built the same. They should all fuel the same, and they should all spark at the same time, and so they should all have the equal amount of push on the crankshaft and create the same acceleration speed. So that's what we are looking for, a difference in acceleration speed. And just like before, if we use our intake to kind of guide us to a possible point of misfiring, we have those blips, we'll call them. And if you look closely at the black channel, we kind of have, at least here it was really misfiring bad. It's easier to see from this far away view, large fluctuations there and here, and there's some there. But we'll zoom in, and I will show you what that looks like. First, we'll try to go to this area to try to explain how that math channel works. So if we pick a certain point, let's move a blue channel up. So if we go, let's say here, and you kind of have to use your imagination, but let's set up our rulers and kind of get you to where we can see the acceleration. So if we build our 720 graph or segments and split up in 8, so we've got 1, 2, 3, 4, 5, 6, 7, 8 back to cylinder 1 in our black channel. So this is ignition strike for cylinder 1. So we have a spark event when this blue line occurs. And after that, we have to accelerate the crankshaft. So this is when you see this black line go up. When this rises, it's acceleration. When it goes down, it's a decel. So we spark right here, and then we accelerate the crankshaft. This line, this line, this line, this are all the sparking events in firing order, equally spaced out in 90 degrees for each other cylinder. So it's 1, 5, 4, 2, 6, 3, 7, 8, back to 1. So each time those lines appear, that's ignition strike. So cylinder 1, we accelerate the crankshaft. Cylinder 5, we accelerate the crankshaft. And then 4 up, 2. This drop down, if you see a drop down here, you see a drop down here, you see a drop down here, here, and here. That point, that is the segment that of the tooth that's missing on the crankshaft trigger wheel. So you can't, you have to understand we're going to have a drop in our signal because there's no teeth, or there's not a tooth there. So we have to use our imagination because we lose the signal, but you've got to look at where that ending point is on the continuation point. If we're ending here, that means we had the travel here. So this one sparked, it goes up. So it was 1, 5, 4, 2. So that was 2. And then 6 fires goes up. 3 fire, it goes up. 7 fire, it goes up. 8 fires, and then we end up here, it goes up. So that is the basis. We're using this black channel and the uprise humps in the black channel to see the crankshaft speed up. And so we'll back out to a portion where we misfired and look at the same humps, and we should, or in theory, we are wanting to see the 8 humps accelerating, but because we have misfires going on, you'll see that there is a drop. So here already, and when it starts to wave down, we know we're losing contribution of speed. So it already looks different without us even getting in deep detail. So let's go. So we're going to take a look here just before it gets really, really bad, and try to explain and show you what's going on. So let's see. If we, from this point of view, again, look at our ignition strikes, and I know it travels down, and then it picks up, and then it travels down. But you have to look and understand as to why we're getting this fluctuation. So what is happening is, first of all, let's look for our non-contributing cylinder. So we have cylinder 1 that fires, we have acceleration. The next one, 5, it accelerates there. Then number 4, it accelerates. This one is 2, it accelerates, and it starts to pick back up. Next one, number 6, and it accelerates. Number 3, it accelerates. Number 7, it accelerates there. Then number 8, it just drops. So that point to that point is a drop. You can see it a little better there. So uprise, 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 uprise. We have an uprise here. And this one, no contributing uprise. It just, from there, it goes down to there. So that misfired. That is, this line here is cylinder 8 ignition. It never sped up the crankshaft in that section. It went from there all the way to here. It didn't contribute. And so, and the reason why we have this dip and then the rise, like, dip, rise, is because we lose so much speed from non-contributing number 8 here that the crankshaft speed went from being all the way up here to slows down here, even with these guys trying to get it back up. And then enough cylinders contribute to where it starts to gain speed again, and then boom, again we have a dead hole, and we've slowed down even though these guys are trying to keep it up, and then they get the speed back up. So that's the reason why we have our fluctuations, is because we have one cylinder right here, number 8, that never accelerates the crankshaft like these other guys do. And so it drops in speed. That's how we know 100% we have number 8 misfiring. And just one last look to reaffirm, and this is when it's a little bit in the worse condition. We have speed up, 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 and then drop down. Number 8, no acceleration. Okay, so now that we know that cylinder 8 at idle doesn't contribute the same as the other cylinders, I decided to go on a test drive again because the customer had expressed that this is where he can also feel it more prominent when he goes down the road, gets on it, and it'll misfire, and then you can shut it off, cycle key, and it'll feel normal until, again, you go driving down the road. So we have the same concept here, same channels. Ignition 1, our black channel is our math channel based off of our red crankshaft sensor signal, and then the green is our intake. Now the way that the math channel, again, it is giving us our crankshaft speed, and so this is a test drive. The higher it goes, the faster the speed, and when it comes down, the slower the speed. So this is speed of the engine, but you can attribute that to how the vehicle is going to move. So if you use your imagination, we are driving, going fast because our RPMs are up fast, high, and then we slow down maybe at idle or just cruising without accelerating, and then we drive again because we raise RPM, let off, raise RPM, and these are actually, I think, shift points. So it's driving, drops down, shifts, picks up, shifts, picks up, shifts, picks up. And then if you look at our green channel, that's how I can tell or depict when it misfired. So I let off the gas pedal as soon as the engine light was flashing, and we had what we were now feeling a true dead miss. I let off the gas pedal, and so our intake just dropped. That's because the throttle body closed, and we went straight down to full vacuum. And so just before that is now where I know that something occurred to make the engine computer start flashing the light. So that's kind of a marker point for me to look just to the left before the intake vacuum was at full level down here. And before, I showed you how the math channel can give us an idea of what cylinder is not contributing. And let's look down over here again, just for examples of how the engine is running. Now, I'm not putting up my ruler's markers, but we can see beautiful and perfect contribution. Not one is dropping out. So we've got 1, 2, 3, 4, 5, 6, 7, 8, back to 1. Now we don't know which one is which because I'm not using my sync, but all 8 are contributing right there. It's running good and smooth. Their crankshaft is accelerating pretty much equally with all cylinders at that point. Now this is all during that same test drive. This is this measurement here. We're going to look here. So this is, again, this is the crazy thing, how this vehicle, this engine, how it happens, when it happens, and I'm showing you perfect example of no issue occurring right now. And then we'll get over to the higher acceleration point, which I have marked there, and we'll look and I can show you there. Now at that point, I'll show you, our math channel is not set up to pick up in good detail. At this frequency and point RPM, I'd have to change all the settings and stuff to try to pick up a good crankshaft speed acceleration point. Again, this is all built off of a math channel, and but what I can do is show you this point. So we are going to look at our intake trace. Again, this is something that is occurring just before the check engine light. So once the check engine light starts flashing, the computer is now up to this point, up to that point, seen that the crankshaft speed has not matched in all 8, and then it cuts out the injector to protect itself from damaging the cat, and it shuts the injector because it knows the cylinder is not contributing, and it doesn't want to fire fuel into the cylinder because it's not burning all of it. It doesn't want to dump fuel into the exhaust to damage the cat. So prior to that, there has to be an issue, and that's what I'm looking for. And in my intake trace, let's see, the green channel, I'll move you over this way. If you remember, we in our intake pulses, you want to see all even pulls. And right now, we are seeing an anomaly or something that is different from the rest. So there's a point there, a point there, a point there, a point there. Now this is repetitive at this time and moment. This is how this is, let's call it failing, or we're seeing an anomaly at this point during the hard acceleration. Okay, and so to try to explain as to what we're seeing or what is going on, let's see. We have to try to understand what's going on. So each time that this travels downward, it's supposed to be an intake pull. And we can see a pull here, a pull here, a pull occurred, something else happened, and then we've got an attempt of pull, 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 and then we start over again. So there's again 1, 2, 3, 4, 5, 6, 7, 8 cylinders. We should have 8 even pulls, but this is under hard acceleration, and the computer's decided that there's an issue, something's not running right, not burning right, so on and so forth. We are tapped into the intake manifold, and we are seeing a pressure issue occurring right here. A pull is happening, a pull is happening, a pull is happening, but here at this point, a pull got cut off from continuing. Now, this is in vacuum. The higher the vacuum level means the further it travels down. So we're going to a further vacuum level, the lower we go. The higher our reading is less vacuum or higher positive pressure. What happened here during this pull got interrupted by introduction of positive pressure during this, let's call it cylinder stroke. So it was this cylinder, whichever cylinder that was at that time, was trying to pull like the others, but got interrupted with positive pressure shooting into the intake manifold. Now, in order to identify that, we have to understand what's going on. So we're using our sync. This is cylinder 1 ignition. Again, our firing order. So 1, 5, 4, 2, 6, 3, 7, 8. But as far as our intake pull events, we have to use some identification, and the best way I have found is the cylinder that you are synced on, which is cylinder 1, you go to 360 and you go to the right of 360, and that'll identify intake pull for the cylinder you are synced. So in reality, this is pull for cylinder 1, this is the pull for cylinder 5, this is the pull for cylinder 4, this is the pull for cylinder 2, this is the pull for cylinder 6, pull for cylinder 3, pull for cylinder 7, pull for cylinder, let's see, 8, right here. So at 360, this is cylinder 1, this is cylinder 8. But the one I am looking at is right here, getting cut off. If you look here at our firing order, I've split it for companion cylinders. So 2 and 8 are companion cylinders, 4, 7, 5, 3, 1, 6. And so if we look at this with our firing order, so this is cylinder 1, this is cylinder 5. Forgive me. These points are top dead center points, meaning the piston for whichever cylinder is at top dead center at these points, basically when we're having ignition. So peak point for cylinder 1, peak point for cylinder 5, peak point for cylinder 4, peak point for cylinder 2, peak point for cylinder 6, peak point for 3, 7, and 8. And so this section here, our cylinder 2 is here. So 1, 5, 4, 2. This is 2. That means piston for 2 has gone and traveled all the way up to this point. So activity before it reached peak point, top dead center, this is area where we're having an issue. But which other one is traveling upwards towards top dead center? That is cylinder number 8, as we saw our companion cylinders 2 and 8. That means those are traveling in the same direction. Number 2 is traveling upwards to get to this peak for compression stroke. But our companion cylinder number 8 is traveling upwards in our exhaust stroke. So it's trying to push air out of the exhaust valve. But our intake valve for cylinder 8 is leaking because cylinder 8 is now traveling upwards, trying to push that high pressure of exhaust out. But we have positive pressure that's introduced into the intake manifold because we can see that this pull got cut off soon and pressure went up in this area. Now, yes, it could be cylinder 2 because it's going up on compression, but we know it's going to be cylinder 8 because that's the one that we're having misfires on or not contributing as much as the others, as we confirm with our crankshaft speed sensor signal. So, again, I hope you understand. These lines are peak points for piston position. It's top dead center points for all our pistons. This section, 90 degrees worth, so it's 2 columns, is when the piston is bottom dead center and travels all the way up. Cylinder 2, this is its peak point for compression, but it's also our peak point for cylinder 8 exhaust. It's traveling upwards in the cylinder, pushing all those gases up close to the chamber, top of the chamber, and out of the exhaust valve. But because our intake valve, one of our intake valve is not sealing, it's bleeding off pressure into the intake manifold. That's what we're seeing there. Now that's just one of my captures. If you look there, this is a test drive, misfiring, so on and so forth. And if I got a second capture of a test drive, and that is this one here. I believe this is the one that was actually caught on the camera that I did film and got you guys to see the check engine light flashing. Again, we are at a high speed, we come down, we accelerate hard, shift through the gears, and at this point where our intake green channel just shoots down, that's my marker point to look somewhere beforehand for an issue. And again, our math channel at those speeds doesn't really give us a good insight. But if we look deep, and just to show you that this is So I've labeled this test drive number 2. So I've captured the same event, test drove it, got it to Misfire, and now I'm looking for anomalies or issues. And as I already know, I'm going towards intake to see what I can find. Again, we're trying to pinpoint and verify what we are suspecting is a leaking intake valve. And if we look at our intake trace, again, this is during higher acceleration. We are seeing what I'm going to call a repetitive anomaly, something that shouldn't really be happening. And you can see it throughout at this point. So there, 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 and so on. So there's something that is going on. Again, keep in mind, this is the same engine. This is just a second different test drive. This one actually took me a while to get it to misfire. It was accelerating hard, didn't misfire. It had to go around the block, I think it was about 4 times, as opposed to the first capture you saw. That was right away leaving the shop, 1 blast down the road, I got it to misfire. Then I sat down, saved the capture, went for a test drive, and on camera I did edit out, but it took a while, again about 4 or 5 laps around the block to finally get it to do it. And this is how this time it failed, or this is what we are capturing. Same engine, same misfiring end result, shutting down same cylinder, but look at what we have. We have a different anomaly happening in our intake trace. We are always synced with our markers at the same point with ignition cylinder 1 in that blue trace. If you remember, that was happening somewhere in this region before 360, which was cylinder 2, top dead center, and cylinder 8, top dead center. Nothing really bad, quote unquote, is happening there. But look what we have now. It's more towards the right. And as I explained, these are peak points for our cylinder top dead center events. And we go 1, 5, 4, 2, 6, 3, 7, 8, back to 1. 8 is here. Our anomaly is here. Our piston is rising, within these 2 columns, 90 degrees. From this point to this point, our cylinder 8 is going up on compression. And we are seeing this, again, anomaly of cutting off a pull. So we've got a pull here, a pull here, a pull here, pull here, pull here, a pull that got cut off here, and then pull here, and then a pull here. Another way, or another point that we can see is basically, look how you got smooth, 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 as far as the line, the travel for the pull. And then here, it's kind of like turbulent. It's all shaky and whatnot, this whole section here. That is basically air that's seeping past our intake valve for cylinder 8, going on compression. That's all 4 valves should be closing or closed, and air that has seeped out or seeping out of our intake valve into the intake manifold plenum chamber area is fluttered, let's call it. So instead of being smoothly traveled, we have an interruption or interference. We have air shooting into there, and it's causing that signal to flutter. That is because, again, our piston is pushing all that air, compressing it, and it's going past the intake valve till it reaches top dead center right here, and it's interrupting the events in the chamber. It cuts off this pull early, and it introduces that flutter, and that right there gives us another nail on the coffin that cylinder 8 is our problematic cylinder through our intake valves not sealing. And we're seeing it happen here during the upward travel of compression for cylinder 8, affecting the intake chamber pulls. And then we saw it here when cylinder 8 was traveling up in our exhaust stroke, when it should not bleed off through our intake valves, because it's only shooting should be shooting pressure out of the exhaust open valve, but it was introduced into our intake plenum again there as well. So 2 points of failure in our intake trace waveform from the same engine, caused by the same cylinder faulty intake valves. All right, so based off of the scope captures, my I think last step is going to go to in cylinder to try to see if we can find a difference. I'm going to look at cylinder number 8 and then number 1 as a base to compare number 8 to. And the engine is cold. I'd like to do these with a cold engine first startup, and then we'll go ahead with idle. And we'll stop that. And right off the bat, I can already tell a crazy difference. So for starters, the channel labeling is blue is cylinder 1, red is cylinder 8, and I have green for intake again. But let's take a look at this. This is kind of wild. I wasn't expecting this. We'll break it down. So we've got our first startup. Here's our 2 cylinders, about the same. Slight at the peak, slight difference in peak pressure, but watch this as we move on. So we'll move. And right there, look. Oh man, this is crazy. Look at that. Look at the red dipping down while the blue stays up. Now, red is cylinder 8. We are dropping in pressure. We are, let's see. Look at that. So the deeper exhaust pocket also signifies the difference in physical pressure. As you can see, yeah, let's and just for giggles to get some numbers. Wow, so look at that big difference. So the red dips down, that's somewhere around there, and let's get a number for the blue. So there are hard comparison numbers. So 80 to 46. That is a big difference there. That's we're capturing physical pressure difference readings that we should not have. Over here, even the red, just it dips down, back up. all while, let's see, the blue stays consistent. So that there in our intake stayed flat. So this going from higher or higher to low, low, back up, back up, back up, while this bank stayed high. That is a clear indication of pressure loss, bleed off, valve, upper end sealing issue right there. And it, as far as the number, it's down to 40 psi. So it dropped down, what, 6-7 psi at that point. Let's see, let's keep going just to see. I mean, but this definitely is, talk about nail in the coffin. And looks like blue's coming down, so I think the idle is starting to maybe try to stabilize. Maybe. And now we're getting a little bit of a rise, because now we get into our idle surge, where it kind of turns into a wave. So it's not the best to be trying to look at, but even then, clear pressure difference. And then we shut it off. So not much more there. We're getting our for sure evidence right there. Okay, so that right there, again, is our final dagger. In cylinder, in both banks, cylinder 8, cylinder 1. Clearly see a difference. Physical pressure difference, cylinder, which we should not have. Number 8 is coming out lower. Number 8 is our trouble child, from scanner code to our misfiring that we're picking up physically with the math channel. Number 8 is causing what I believe some of that turbulence in the intake pulse or waveform, and it's just it's not maintaining all of its compression, and it's causing it to misfire. So unfortunately for the customer, a lot of time, money, and effort has gone into other things that won't take care of this issue. This is going to be an engine mechanical repair, and there's no way around it. So I hope you guys enjoyed it and learned something from it, from the scope captures and all the data that I've given. And I will be notifying the customer. Again, he came a long way, so I made sure to do as much as I can to pinpoint 100%. That way he can leave with a true answer. But I'll get with the customer, with you guys. So thank you for watching. That's it for this one, and we'll catch you on the next one. So as far as the revving, not much different, bank to bank. One thing to note, I wanted to point out on this. See this rise right here towards the end of the exhaust strokes? Some people can confuse that as some will say clogged cat, some can say that it's because of turbos or whatnot, but what you are seeing there is actual exhaust cam phasing occurring. It's advancing it, and so it's closing the exhaust valve sooner, and you're seeing a rise in pressure still during the exhaust stroke when the piston's going up before dropping down for the intake stroke. So this vehicle is perfectly fine other than the misfire, but timing and all this, all that, no clock cats or whatever. This is what you are seeing, and keep that in mind for other cars. That peak there towards the end, that's exhaust cam phasing, and you can tell it happens during the when we rev it up. And lastly, let's take a look at the intake. And right away, even from this far away view, you can see there, kind of those gap points. And look, repetitive. So right there. So we're continuously having an anomaly again there in the intake trace during the idle, and when we are making less pressure there. So again, and believing that it is going to be an intake valve sealing issue. Yeah, so see it there. It's continuous. You can't get away from it. We're seeing it in the intake trace when we're making less compression pressure than the other bank, because we are not sealing in our upper end.